Hey class, hope you're doing well today. What we're going to discuss today and for the next couple days in class are what are called parametric curves. And parametric curves are a simple way to formalize how a curve could be written in 2 dimensions. For that matter, we could easily extend what we're about to learn into 2 or 3 or more dimensions than that. But in Calc B, we're going to restrict ourselves into just 2 dimensions. So check out today's big picture video. All right, so like I just mentioned, we're going to discuss what are called parametric curves. And what I want to start with is basically how we've been thinking about functions and curves in 2 dimensions up to this point. So if we take the notion of what a function is, it's basically an input-output type process. A function for us, we take an input, which typically we think about as x, and we get one unique output, which is typically our y. So we're used to seeing sort of the following definition of what a function is, that for one input x, we get one output y, where y is a function of x. And the way in which we could test whether or not something could or could not be a function was through what we had called the vertical line test. So if you remember the vertical line test, just to quickly show ourselves, it was the idea where if we have some curve in 2 dimensions, if we just drew a vertical line through it, we just want to make sure that for one particular x value, there is only one unique y value associated with it. And where we're going to go today is, well, what happens if we have curves that don't satisfy this? So for example, what if we have something like a spiral? Where we know if we try to do the vertical line test, that on this spiral, for one particular x value, there are multiple y values associated with it. So this spiral would not be a function in the traditional sense that we know functions to be. An input x associated with one unique output y. But what we're going to do is figure out how to mathematically represent this curve, this spiral even, using what are called parametric equations. So in today's videos, what we're going to discuss are the differences between parametric curves and what we call Cartesian curves, or Cartesian functions, where we have direct relationships between a variable x and a variable y. We're going to learn how to take a parametric curve and then decompose it into individual functions of x versus t and y versus t, where what we're calling t is the parameter. We're going to learn how to plot parametric curves a couple different ways, making a table that should feel very reminiscent to how we plotted functions when we first started learning things like lines or parabolas, as well as how we can take plots of the individual x versus t and y versus t functions to plot a parametric curve on the xy plane. Then we're going to learn how to go back and forth between parametric representations of curves and the Cartesian representations. And this is what I deem eliminating the parameter t, or eliminating the parameter. Next, we're going to see how nice and convenient it is to just be able to translate or scale parametric curves if we want to just move a parametric curve around the xy plane, or if we want to magnify it, make it the entire thing larger or smaller. These are both very, very easy manipulations for us to do. And finally, we're going to close with one short application where we discuss that basically we can define different types of fonts like you would use on a computer using this idea of parametric curves, something people tend not to think about right when you start learning this mathematical formalism. And just to end this big picture, the way in which I think about parametric curves, the most naturally way, at least for myself, is I imagine myself walking around an xy plane. And if I'm walking around an xy plane, well, my path could do a bunch of wonky things. And I'm just drawing some arrows to indicate sort of my path as I move around. And the main idea is, well, there is a coordinate x that's describing where I am in the x direction, a coordinate y describing where I am in the y direction. And as I'm walking around, both the x and y values are changing. And because I'm walking, they're changing with respect to time. So you could think of time as the parameter. So as we go along in all of these videos thinking about parametric curves, in the back of my head, I'm thinking, okay, things are changing with respect to time. It gives me a very intuitive grasp of how to think about the x component and y component individually. With that, please watch the remaining videos, and looking forward to seeing you in class.